everyone. Thanks for joining us for our next session with Wallaroo.ai, deploying and monitoring LLM inference endpoints. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours right here on the Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Please stand by. Hi, Martin. Thanks for joining us today.
Hey, Anna. Thanks very much. I appreciate everybody joining us today on this session. Just give me a second. I actually got cut off just before I was about to start, and so I'm just going to share my screen and my deck, and we'll get cracking on here. Apologies for that. Okay, here we go. Everyone see my screen okay? Yeah? Awesome. Okay, I'm Martin Bald, and you've probably seen me on some other Reactor events that we've been through in the previous sessions that we've done here. And today we have the opportunity to go through deploying and monitoring LLM inference endpoints. And so we'll be digging into that a bit. And we do appreciate you taking the time to spend with us on these sessions. I know there's a lot of things vying for your time and attention these days, especially during the workday. And we do appreciate you taking the time to join us here on these sessions. And hopefully we can give you some sort of technical insights into how we handle situations like, deploying and monitoring and making sure that your large language models are, viable, that you're getting the outputs and the performance that you expect from them. So what we'll do is we will go through some introductions. I've got a couple of colleagues with me today on this session that are much more technical than I am. But what we'll do to kick off, we'll go through some use case examples because, there's obviously some scenarios that we know where we'll use LLMs, but there may be others that, you might not be aware of, or there might be others that I have in the list that, you can share with us as well. And, that would be ideal. So we want to make this super conversational. The other thing is we'll go through production challenges, and these just don't apply to LLMs. There's many challenges that organizations come when they're deploying their models into production and keeping them performing to their expectations. And we'll talk about some best practices as well to, not just from a technological standpoint, but then also as the people that we'll work with is, folks like yourselves that are the data scientists and the MLEs that are working with these models, training them, developing them, and then getting them into production. But the bulk of the time that we'll spend today will be actually showing you this. We want to make sure that, these are technical sessions for technical audiences such as yourself. And we'll go into the meat of how do we deploy, how do we monitor these, and we'll also talk about RAG as well for this. We want to keep this interactive, as I said, but we do have some time at the end for Q&A. So please, if you've got any questions, by all means, put them into the chat, and we'll endeavor to get to them as we go through the session or at the end. So just a quick introduction. If this is your first time, welcome and thank you for joining. My name is Martin Bald. I'm the Senior DevRel Community Manager at Wallaroo. I was very fortunate to spend the bulk of my career at Microsoft, both in the field and at corporate. And I've enjoyed roles throughout, different, parts of the organization through partners, technical pre-sales, etc. But the role I enjoyed the most was the last 10 years that I spent with Microsoft in that evangelism and DevRel role, working with the folks like yourselves in the community on, hackathons and, events, engagements, and really seeing how you take technology and apply it to those everyday problems that you come across. And that's the part that I really enjoyed about the job that I had. And so it's great to step after that. There is life after Microsoft, and so I've joined this great company that we are a Microsoft startup and Wallaroo, and so continue that journey with the tech community such as yourselves. I'm going to introduce one of my colleagues now that will join us. And so, Yunus, could you introduce yourself?
Thank you, Martin. Thank you for having me. I'm Yunus Amar. I am the VP of Product here at Wallaroo. So I come to Wallaroo from various experiences focusing on turning basically data and analytics into business value, whether that was something that I've done in ESG or healthcare or insurance or logistics. At heart, I am a developer, just like most of us here at Wallaroo and most of the the community that we're looking to work with. And I'm super fortunate again to be here and share with you some of the insights and learnings from working closely with customers in a field that is evolving quickly, some of the learnings, and also some of the implementations that we have done to support some specific use cases that we'll be showing at the end of or towards the middle of the presentation. So looking forward to that. Very nice to meet everyone. Thank you, Martin.
Thanks, Yunus. Next, I'm going to introduce our next colleague, Akmal.
Hi, everyone. My name is Akmal Sayed, and I'm a senior sales engineer here at Wallaroo. I've been working in data science for about the past decade, and more specifically in AI ML for the past several years. Excited to be here today. I've helped numerous companies and teams get started with AI and ML. So everything from helping define AI use cases to evaluating data to training and deploying ML models. And in my role here at Wallaroo, I continue that journey with a focus on helping customers bring ML to production. And great to be here today. I'm super excited for this session. It should be fun. On that, I'll pass it back to you, Martin.
Fantastic. Thanks very much, Akmal. And I really appreciate yourself and Yunus spending the time to go through this very important topic for folks. And when we look at LLMs and we look at the different industries, use cases, and examples that that these can be leveraged for, there's a number of different industry verticals that you've probably already seen them being used in, or if you are working in this space, there's opportunities there for you to investigate those avenues. And we have experience with some of our customers, like retail, where they're looking for those chatbots to create that customer engagement and improve that that sort of transaction element with customers, and getting back to them with product inquiries, information, and resolving issues that customers have, and just overall improving the efficiency of their day-to-day operations. This also extends into life sciences, where we've seen through COVID, it's been a catalyst for generating adoption of AI. And within healthcare, they deal with a great deal of information, reports and raw data from, like lab experiments and other research documentation. And condensing this and summarizing it makes it a lot easier for these scientists and technicians to act upon this information and really sort of identify certain patterns so that they can get to a solution or get to a patient discovery and treatment a lot quicker. Also within the financial services space, they face the same issues that the life sciences do, with a great deal of information, long documentation that needs to be summarized and condensed for customers, and improving again, and similar to retail, that transaction with customers and that engagement with their customers in giving them the product information, and also training their sales teams and their customer engagement representatives with that product information to improve those customer experiences. We also have experience with some of our customers in the marketing and advertising space. they're looking to, be very connected to the audiences that they want to reach out to tailor content specific to customer behaviors and patterns, and get a lot more personalized with the information that customers are looking for, rather than spamming customers. And so leveraging LLMs has been a great benefit to them. As I said, there's other use cases, and we would love to hear some other use cases that you might be considering, or in the sort of journey towards with large language models. But these deployments and these use cases, they don't come without their challenges. You've probably seen the Gartner reports of 90% of projects fail to make it into production. And that is compounded through a number of different factors. There's, overhead and complexity in engineering, where, data scientists are expected to be full stack engineers and deploying these models, setting up the clusters and managing, the different tools that are needed to get these models into production, to connecting with the DevOps teams and the IT ops teams that are managing the rest of that infrastructure and trying to keep it running and secure at the same time. There's also a significant cost. These models are not small. And so the storage space, the transaction through networking, etc., adds to that cost, as well as we've seen recently the availability of GPUs. Folks looking at, what we need GPUs to run this, or we can't run it at all. The other element that is not just specific to LLMs, but weighs heavily on it, is that security. Maintaining the integrity of the data, also compliance as well. We're seeing nation governments putting in legislation that has impact on large language models and how companies manage and work with that data. The other important part is bias and risks, and that hallucinations that folks deal with, and that sort of credibility factor that customers are expecting. You may have seen some of the public cases that are out there right now. One of them that I saw was Air Canada, where someone was looking for information on getting a refund on a bereavement fare, and the chatbot said, "Yeah, we do that." And then Air Canada turned around and said, "No, we don't." And it got taken to court, and the courts, Air Canada said, "Well, the chatbot doesn't speak for us," but the judge says, "Yes, it does." And so, while that is a low cost, is about $800 or $900 for that customer, the public impact of that can be widespread and significant in the trust and credibility for that customer. And so that's where these challenges that we want to try and mitigate from the very beginning when we deploy into production. And there's some best practices that we can apply to that to help us on that journey. The first thing is, looking at your ecosystem that you already have. Customers have made, investments in, ecosystems already. They have clouds, they have on-premises data centers, and, investigating edge, deployments as well. And leveraging that infrastructure is a huge opportunity, which gets you to that, return on investment and showing the value of those models quickly. There's also the opportunity to monitor those models once they go into production. When you deploy a model, there is a high probability that you're going to see some data drift. Being able to act proactively on them, take that data back into your your ML ops and your monitoring cycles, so that you can act on them quickly, so that those public embarrassments don't become a reality, and that you can actually work with them and resolve them before they become an issue. The other part is scaling as well. You're not just deploying one model into production. You're probably going to be deploying multiple models into production in different geographies. In the case of Edge AI, you're probably going to be deploying to hundreds, if not thousands, of devices. And that scale and manageability needs to be automated, and taking away that manual element and giving the bandwidth back to the data scientists and MLEs, so that they can automate that process seamlessly, and run those batch models when they need to be run, and whatever endpoint they need to be run in. So these are some of the best practices that we sort of see when we work with customers. And again, if there's others, definitely we want to hear from you in the audience to say what other best practices have you come across. And as we work with our customers, this is who we are. Those challenges were the sort of the catalyst for the creation of Wallaroo. We had a Series A Microsoft funded startup. We had a Microsoft partner and part of the Microsoft for Startups group, as well as the Pegasus program. And creating that inference platform for production AI at scale is built into the DNA within the inference platform, regardless of whatever data scientist or ML models you're creating. We want to make sure that you can roll that right into production and have that sort of portability of taking it from pre-production into production. I worked on some projects, in the previous role where production is an afterthought, and it needs to be part and parcel of the whole project from the very beginning. And not just that, but creating, giving the data scientists and MLEs the tools that are familiar to them, such as Jupyter notebooks, so they can work in those environments in a familiar context. So we're not having to go set them, into retraining and something that's out of their sort of comfort zone. We want to make sure that these folks can take those models, roll them right into production, regardless of the model framework, or if it's a custom Python framework that you've built in-house, and then deploy that to whatever endpoint you want, whether it's in the cloud, whether it's on premises, or a remote other sort of geographical region, or also edge locations as well. We're seeing a huge momentum towards edge as the power of those devices is stepping up. And now we're seeing the advent of AI chips as well, which will increase the momentum and deployment into those edge locations. And so that's who we are. We don't just work with production models. We help you in that post-production space to observe, to automate, and to manage those models at scale, regardless of where they are deployed, with that centralized manageability as well. Now, that's all well and good. So we talk about the industries. I talk about the how we handle them. And from the customers that we do have, we do get certain sort of situations that we roll into. We work as a partnership with our customers, but we do get natural questions coming up from customers that are looking to deploy these models into production. And this is where I'd like to bring in Eunice into the conversation. Eunice engages with customers on a day-to-day basis. He's not just a product, VP within the organization. He's very much in front with the customer and working with them. And Eunice, one question that we've sort of discussed and has come up that you get is customers look at OpenAI and they think, hey, can I just deploy this OpenAI, can I open up the endpoint, what are the implications of that, or do I have to deploy my or create my model from scratch in-house, and what are the implications of both those scenarios?
Thank you, Martin. I thought you were going to ask me which part I enjoy the most. Is it talking to customers or building product? I do enjoy talking to customers a lot. So on that note, actually, when we get the question, by the way, we see Wallaroo, what you guys do. Now, OpenAI is there. We have our own inference endpoints there. Why do I need Wallaroo? The answer we provide is two things. The first one is, it's two parts. The first part is really from the perspective that when it comes to building effective LLMs to power your next generation AI-enabled products, it's not just about spinning up that inference endpoint and you're off to the races. That's somewhat of a misconception, and that's likely how you see issues similar to what Martin mentioned earlier with hallucinations and brand damage and things like that. So effectively, what you want to do is not just deploy the LLM, but add more things to it, which is something we will show later in the presentation. But the answer we provide is that yes, if you want to get started with Wallaroo, to take advantage of the additional monitoring and management capabilities to quickly iterate on the LLMs post deployment, we do have basically capabilities to allow wrapping those inference endpoints. Say you set them up in OpenAI or another service, you can actually bring them into Wallaroo using our Python wrappers to actually stand up the endpoints and then take advantage of the inference pipeline capabilities within Wallaroo to add the management monitoring capabilities. So with that, Martin, I don't know if there's anything in particular you want me to answer, or I think it's probably worth showing it in a demo. That will be better than just talking about it.
Yeah, let's get into the technical.
Okay, awesome. Thank you very much, Martin and Eunice. I'm looking at the comments. I don't see anyone from Toronto, so I'm going to give a shout out to Toronto. I'm in Toronto. I see Seattle, but I'm going to give a shout out to Toronto. But yes, before I get into how we can integrate OpenAI with Wallaroo, I want to take a step back to quickly show how we can get started with Wallaroo in Python. And so you'll see that I'm sharing a Jupyter Notebook, which will be our Python development environment for today. But more importantly, I wanted to bring your attention to this import Wallaroo statement here. So just like any other Python library, Wallaroo is pip installable. And this SDK is really our interface to interacting with Wallaroo using Python. So for today, this will be our workhorse for the session. And so as Martin pointed out earlier, because Wallaroo is installed on your cloud or on-prem, you can do what we'll show today in any Python development environment that has access to your installed Wallaroo. And so once we've imported our libraries, we can connect to our Wallaroo client and our workspace. And now that we've done that, we can now look at the 3 steps which will help us integrate OpenAI into Wallaroo. And I just want to scroll down here and expand this. And over here, for integrating OpenAI into Wallaroo, what we're going to do is actually, we're going to take advantage of Wallaroo's lightweight and flexible BYOP framework. BYOP stands for Bring Your Own Predict framework, and that will help us with that integration. And so in our first step over here, I'm going to expand this cell. In our first step over here, we'll upload our BYOP model. And this BYOP model will be our OpenAI wrapper. And so to upload it, we'll tell Wallaroo the name of our model, the file path of where this BYOP can be found, the framework, and framework here custom represents BYOP, and then the input and output schemas. And so our input and output schemas are the way in which our OpenAI wrapper expects to receive input and output data. So it expects to receive the data and output the data. But something I want to dig into is this Wallaroo BYOP framework that I'm talking about. And so to do that, what we're going to do is we're actually going to dig into this zip file over here. And so you can see it's in the models folder. And so if I open that up, right, I have this GPT-35.zip, and I actually unpacked it beforehand so we don't have to wait for me to unzip it. And so when I'm here, right, this is the file structure of our BYOP or utilizing the BYOP framework. And so as you can see, just unpacking it, it's very light in terms of its file structure, right? There's a requirements file, right? There's a secret key JSON file, which contains our OpenAI API. And then we have the main.py file, right? And so I actually want to open this up. And over here, we're able to see the BYOP framework. It's a very light and flexible framework, right? And it allows us to really customize our models. And it really consists of 2 classes. And so the first class is a class which inherits inference builder, and the second is a class which inherits inference, right? And so the class which inherits inference builder, right? You can imagine by its name, Inference Builder, what we do is we actually load our model over there. And so us using our OpenAI API, we're going to define in this situation, we're going to define the model to be the OpenAI client. And then in the inference, right, this is where we actually implement our workflow. So the class which inherits inference, we go ahead and we can define or implement our predict function. And so this predict function is actually exactly what you would expect from an implementation of OpenAI's API. We have our chat completions API, right? We're making use of GPT 3.5 or 3.5, whatever you like to call it. And then we have our prompt, and then we have whatever configurations we'd like to set. And so this is what takes that, wraps up the OpenAI API lightly, and then we end up getting our model. And so you can see that we're able to implement our GPT 3.5 workflow. And like I said, it's exactly what we expect when implementing our OpenAI's API. And that's really the magic of the BYOP framework. Like I said, it's a very lightweight, flexible framework. And so now when we go back to our notebook over here, we can go on to our steps 2 and 3. And steps 2 of deploying our wrapper is our configuration of our deployment. And so over here, Wallaroo being installed on Kubernetes, this abstraction makes Kubernetes fun and easy to use. Over here, we'll assign some CPU, right, to our Wallaroo engine and all along with some memory. But we'll also assign it to our OpenAI wrapper. And because we're keeping it very lean, the great part is we can assign it a fraction of a CPU and very little memory to it. And so that's our configuration of our deployment. And so after we're done that, we can move on to step 3. And step 3 over here is really where we can go ahead and take our OpenAI wrapper, our configurations, and deploy our pipeline. And so once we're deployed, right, we're able to infer on it. And so let me open up this one over here. What we have is we have a prompt over here. And this prompt where we're trying to summarize a text into one sentence, what we do is we place it into a pandas data frame, right? And now with the help of Wallaroo's infer function, we're able to go ahead, let me do this, and let me run this. I just need to log in again. Okay, so now what we're able to do is get our inference back. And our inference, it returns our prompt, so our original prompt, our generated text, and we get a few other columns. But what I really want to say is you're able to see that in 3 steps, we were able to get OpenAI integrated into Wallaroo by taking advantage of Wallaroo's BYOP framework. And before I pass it back to Martin and Eunice, I just want to leave this as a teaser. And that teaser is that we're going to see how the framework, the flow, and the pipeline we just went over really comes to fruition later in this session. And so on that note, I'm going to pass it back to you, Martin.
Thanks very much, Akmal. Great. And I think the other thing that you see there, as I talk about, the sort of DNA that is in the inference platform within Wallaroo is that time to deploy. Getting it deployed within a matter of seconds and minutes instead of days, weeks, months. And that's a huge difference to getting your models deployed. One of the other things when I go through the community threads and see folks discussion on LLMs is we talked about biases and hallucinations and so on. There's a lot of discussion around RAG as well. And I'll bring Eunice back into the conversation here, again, from his customer experience and other engagements is, Eunice, when do I know that I need RAG, for a production, and, how do I deploy that, and what difference does it make to, my models?
Thank you, Martin. Really, so from talking to our customers who are also AI practitioners, which is going to show a strong overlap with what the community is saying. RAG has emerged as a good solution when you have a massive surface area to cover when it comes to your data, and you want to very much control the context of the answer that you want to provide. So let's say in our customer scenarios, the ones that we're seeing today in production are typically chatbots that are going to be answering very, very specific questions from folks who are coming in. And you think about especially highly regulated scenarios, think healthcare, financial services. This is where we're seeing this solution being super effective to reduce hallucinations, but also to minimize the compliance risk. So from a reasoning perspective, in terms of the data that you want to cover and the quality of the answer that you want to generate, and also one thing that sometimes we don't talk about much is the cost of basically generating that answer and also mitigating a wrong answer is really where this solution can be effective. An example of mitigating the wrong answer means that you can spin up a chatbot pretty much overnight. There are apps to do that. But then if you're in a highly regulated sector, you enable the chatbot to provide answers that those answers might not be satisfactory to the customer. Then you get an escalation, you get tickets, help desk tickets to resolve. Then you have now your human agents being involved in the conversation, which adds a lot of cost to service those customers, and also customer satisfaction is at risk. So those are scenarios beyond the, again, as I mentioned, the size of the data you want to cover, the models. There's the cost implications that need to be accounted for. And in terms of an implementation and how we implement it at Walru, we always strive to be as modular as possible when it comes to the actual LLM that you bring in. So you have the flexibility to bring something from an endpoint, from managed service, or from something that you build locally, and then the retrieval augmented generation steps can be added additionally to that model, so you can actually have that flexibility to stitch things together and build this comprehensive pipeline that you can manage effectively. So without further ado, I think we're probably due for a demo, unless Martin, you want to add something in particular.
Yeah, we actually have a questions from the audience. So Krishid was asking, he wanted to hear just one more time about what our differentiators are, and specifically he's heard about MLOps and wrappers around the API to integrate Open API, but he's saying aren't there other companies also proposing this?
Yes, that is effectively a thing where everyone is proposing API wrappers today. The thing that we propose in Walru is the comprehensive inference pipeline that basically may include that wrapper, but also it will include additional steps that you can add inline to that wrapper, so you can actually get all the monitoring analytics and be able to iterate directly on those models, on those LLMs behind that inference pipeline. So the front of that inference pipeline will be that endpoint that the application will consume. What happens behind it is fully self-service and can be managed by a data science team or ML engineering team without causing any business interruption. And that's really one of the core differentiating factors for us, where our customers are able to do a lot of these things that scale in production with minimal interruption, minimal overhead, and be able to effectively stand them up quickly. Not to mention also the full abstraction layer that we offer on top of the infrastructure that will be required to build these models, stand them up, and scale them out.
Great. Thanks very much, Yunus. Yeah, so we could move on to the demo.
I think the demo is also going to be a good illustration of those differentiators. So
Yes, perfect. Thank you, Yunus, Martin. I think that's a good segue into what we're going to look at right now. And so actually, I'm going to scroll down a bit. And so what we saw previously was we saw how we could integrate a closed source LLM, so OpenAI, with Walru. But this time we'll look at how we can use Walru to implement RAG on an open source LLM. In this case, it's Llama. And so the best part is that we can reuse the steps, the framework, and the pipeline idea we went over previously to help us with that. And so we'll look at llama with RAG, and I'm just going to expand this over here. And so to do this, to do llama with RAG, we're going to be looking at two BYOP models. And so the first is the embedding of the prompt. So this BYOP model takes care of embedding of the prompt. And the second is the vector database lookup and the generation of the text. And so for our first step, we upload our models, right? The first step that we saw before, and we upload both our models in this instance. For both the embedding and the RAG with llama models, just like before, we have our, our name, our file path, our framework, and our input output schemas. You can see that with this model and also with this model over here. But also, what I really want to do this time is I want to jump back and dissect the zip files like we did last time, but this time around, I'm sure you'll see a lot of familiarity with this. And so when I open up the BYOP model, you can see that the embedding model is BYOP BG base pipe.zip. So I have it over here. I've unzipped it already beforehand. And when I open it up, we find that it has the same light file structure that we had before. We have a requirements file, we have our main.py. This time we have an artifacts folder. In that we have our embedding model, right? That we can make use of. And then one thing I do want to point out is that you can see that the light weight structure kind of extends regardless of the BYOP model. And so I'm going to open up this main.py file. And something that you probably will realize is that we're seeing the same things we saw before. And so this is where we'll really see the flexibility of the BYOP model extended here. We have the same classes which are inherited. We have the inference class, which is inherited up top, and then our inference builder class, which is inherited at the bottom. Our class which inherits inference builder, just like last time, loads our embedding model, right? We have it done over here, and that's what we return. And then our inference, or our class which inherits from inference, goes ahead and does the embedding of our actual prompt, right? So we go ahead and embed, and this is what gets outputted from this model. On the other side, so we have the llama model, right? So if we look at what we uploaded over here, we have the BYOP zip right here. Again, same thing. I have it over here. I've unzipped it beforehand. Same thing you're going to see, that very, very light file structure. We have the requirements file, we have the model or the main py file, and we have the artifacts. In this instance, our artifacts consist of the llama model, right? And so just like we saw before, we have our, again, we've seen this before, not only on the OpenAI wrapper, not only in the embedding model, but we're seeing it here again. And this is really the flexibility that I was talking about. And so we have the class that inherits from inference. We have the class which inherits from inference builder. We go ahead and we load our model, our llama over here, into our inference builder class. And over here, just like we did before, right? We have this kind of same story happening. We can go ahead and define our workflow or implement our workflow in this predict function, right? And so we are connecting to a MongoDB database that is our vector database in this instance. And you can have any, and the best part is you can work with any kind of vector databases. That's what this flexibility allows for. We go ahead, we take our prompt, we have it embedded, we check our vector database to see the most similar chunks, and then we go ahead and generate our text, right? So we have our prompt, we have our context that we got from our MongoDB, and then we have our answer, and that's what is what's outputted to our as our generated text, right? And so you can really see the flexibility of the PYOP framework in action here. And so that's it, right? And so we're able to have so far 3 very different workflows already with just one framework. And now we can go back to our steps 2 and 3 that we saw from before. We can go ahead and configure our deployment, right? Our configuration of our deployment, we get to set how many CPUs and memory each model gets, right? So we have our embedding model over here. We have our Llama with a RAG implementation over here. And then we can go ahead and, just like last time, deploy our pipeline. But before we do, I just want to call out one very special point, or one exception that I want to make a point about over here. And that is that, remember when I said the flexibility of our pipeline and the power that comes with it. And so what we're seeing here is, instead of one model, we can chain multiple models. And this multiple models, and this is kind of going back to the point Yunus was making, this multiple models and this multiple pipeline, this multiple models in a pipeline, this chaining of models allows us to have one pipeline, one endpoint, but really that flexibility and that customization is really coming through over here. And so what we can do is, amazingly, infer the same way we did above, right? So we had our prompt over here. It says, suggest me an action movie, including its name. Something I didn't mention is that our MongoDB vector database is full of kind of movie data. And so this is our prompt. It's going to go ahead and do the, take our prompt, embed it, go ahead and search through our MongoDB database. And then after that, go ahead and generate the text. And so you can see the generated text over here. Something else that I want to point out, which is an Easter egg over here, is that if you see up top here is when we deployed the Llama model, or when we set the memory and the CPUs for it, you see we didn't set any GPUs. Well, the Easter egg here is that we're using Llama with CPU. And so the nice part about this was really not only the flexibility that we saw in terms of the framework, in terms of the pipeline, in terms of the BYOP, but also that Wallaroo really works with your models as they are, right? We didn't retrain this Llama model. We didn't retrain any of the models to fit into Wallaroo. Rather, Wallaroo conforms to the models the way they were trained. And with this little bit of abstraction of the deployment, infrastructure is all taken care of by Wallaroo for us. And that's the main point I want to, one of the main points I want to bring home with this one is that you can see the flexibility, the ease of use, the flexibility and everything. And then the same steps that we did above, we can reuse those same steps to go ahead and deploy Llama with RAG. And so on that point, I wanted to give it back to Martin. Thanks.
Awesome. Thanks, Kamal. Great to see that. And as I talked about, there's, I see a lot of dialogue around RAG, a lot of people, in the community sort of talking about, discussing it, looking for, that solution to, keep these models, operating for and getting the, the output that, the folks that are using them expect. But if I can bring Yunus back in for, one last question on this is, Yunus, RAG is great. Do I have to use RAG, or other alternatives to this that will help me achieve the same, if not better results?
Yes, great question. The short answer is no, you don't have to. There are other techniques that can be used to actually make sure that your LLMs are effective through basically validation and monitoring components that on the Wallaroo side we call LLM listeners. So We actually came up with this concept after working for a few months with some of our customers who were actually doing that in the context of traditional ML, where this was done on different modalities or different customer interactions that, before LLMs, it was on audio primarily, on calls, and these models were there to actually look for specific information on the call, gather sentiment, and things like that, with basically these customers of ours shifting towards LLMs as the interaction method for their customers. The same monitoring and models that were there remained relevant for them. So together with some of our key customers, we came up with this concept of an LLM listener, which is basically a set of models that we built off the shelf, that we offer off the shelf, that can also be customizable to detect and monitor certain behaviors. Could be toxicity, harmful language. It could be bad quality responses, both inline. Basically, if you're looking to generate an alert immediately or even autocorrect that behavior from the LLM, that can be done inline, or offline if you're actually looking to do some further analysis on the LLM interactions, especially if it's something that is done in a more controlled environment. Think of basically you can be doing this in a RAG setting and add these validation and monitoring steps on top of that. That's something that is fully supported in Walrus, as Ekmel mentioned earlier, with the steps that we offer in the inference pipeline. So all of that to show that as part of this framework, you will be able to take these listeners and orchestrate them and generate real-time monitoring reports and metrics to understand how your LLM is behaving. And again, ensure that it's effective in production, driving the ROI for the business, and be able to, more importantly, use again the Walrus framework to iterate on it and keep everything, keep that endpoint static while everything that happens behind it can remain fluid, to allow AI developers to iterate quickly on these LLMs without impacting the bottom line, which is, could be your business reputation, it could be revenue, it could be cost, it could be all of the above. So Martin, I don't know if there's anything else you'd like me to add, but I would rather show this in a demo because we have it.
Yeah, let's do it. Let's get back into the code and the tech. Thank you.
Awesome. Thank you. All right. So this one is the one that gets me excited the most. Not only will we see how LLM listeners help us keep tabs on productionized LLMs, but we'll also see how we can leverage everything we've seen so far to get them implemented. And so let's jump right into it. What we're showing today is our summarization listener. It's one of the off-the-shelf listeners we have at Walrus. And what it does is, given a text and its summary, it scores how well the summary is. And the cool part about this is our summarization listener makes use of our BYOP framework, and that's the flexibility I was talking about. And so we can follow the same 3 steps we've seen previously to go ahead and implement our LLM listener. And so we first upload our listener, right? We've done that here. Again, it's a BYOP, same thing. We have the name, we have the location, the framework, and the schemas. And actually, if we go ahead and open up our listener, which we have over here, we'll see again the same lightweight file structure, and we can go ahead and open up our PI file. Again, the same because it's a BYOP framework. I'm sure we're very familiar with this right now. We have our class that inherits inference builder, and that loads in our model, and then we have the class which inherits inference, and over there we go ahead and in the predict function we implement our workflow. And so what this summarizer actually does is it takes the original text, it takes the summarized text, does embedding on both of them, and then goes ahead and calculates the cosine similarity on those 2 texts. And so because our LLM listeners leverage BYOP frameworks, it helps make them super customizable. And so we're finished here with our LLM listener. We can go back to our notebook and we can go back to our steps 2 and 3 that we're familiar with, right? We've seen above with the OpenAI wrapper, we've seen it with the RAG L and Llama implementation, and over here, it's not any different. So we have our configure deployment over here, and we go ahead and we can configure our deployment hardware, the abstraction of Kubernetes back in action, and then step 3 is the deployment of our pipeline. And over here, again, we're seeing the flexibility of our pipeline come to the rescue. So as you can see, we're using the GPT wrapper, so the OpenAI wrapper that we had above. So we used that previously, and that's the first step in our pipeline over here, right? This then feeds into our listener, and then we have this inline logic, right? So we have the GPT feed into our summarizer listener, and then we have this inline logic. And this really allows us to set a flag as our output exits our pipeline, right? And so this is all in one endpoint. And what we're trying to see is if our score, so our summarization score, is less than 0.75, we can set our incorrect summary flag over here to true. Otherwise, it gets set to false. And we can see it when we go to infer, and we infer exactly the same way as we've been doing before, right? So we try to summarize this sentence into, or sorry, this text into one sentence. And so I have this pandas data frame. I go ahead and I infer on it. And over here, we get to see our score, right? Our score right here is greater than 0.75. And so our incorrect summary came on as false. But if we change this to please summarize this text in 5 words, right? So there's no such thing as a good summary in 5 words. I mean, not for this big of a text. So we take that and we can go ahead and now infer or generate the text with it, generate an output or generate a summary with it. And you can see we have our short summarized text here, and indeed our score is less than 0.75. And so now what happens is our incorrect summary flag comes out as true. And so we can see that this flag signals to our workflow that be alert, the summarization, isn't great. And so now depending on our workflow, we can go ahead and stop it, or we can stop it from being published, or we can have a human in the loop, or depending on the workflow, we can do many different things. And so that's one of the ways of looking at the LLM listener. And the other way is actually via something that we call assays. And assays are Walroo's configurable built-in automated drift detection system, which is highly customizable. And so I have it. I have one made already here on our summarization listener, right? And so we created it with a baseline distribution and a threshold. And so what we're seeing here is the listener outputs are being plotted against the baseline. And so you can see that we've simulated to show that as time progresses, right, the drift gets further and further. And if we click on this outlier here, which is our alert, we get to see its distribution. And so not only that, the great part is if we move on to this tab over here, we can go ahead and look at the individual kind of generated summaries. And I'm just gonna go ahead and you can see that we have, come on. Sometimes when you're trying to, there you go. I'm just gonna scroll down and you can see over here our inferences. If we click on one of these, we can go ahead and look at those individual scores, right? And this is we can dig in, we can not only get the alerts, but then we can dig in to what's really going on. And we can see that, okay, we have the generated, we have the inputted text, we have the generated text, we have the scores, and we can really, really dig into it. And so you can see not only that we can look at individual scores, but also the drift it's coming from. And so with inline listeners and then combining them really with assays, we can see how Walru's LLM listeners help address some of the stresses, because there's so many stresses that come with LLMs in production, but some of the stresses get addressed with LLM listeners, right? And so with that, I wanted to pass it over back to Martin. Thank you.
Fantastic. Yeah, thanks, Akmal. And great questions on the queue. Thanks, Crusade. Great questions coming from this. And it's great to get these questions throughout, but we now have an opportunity at the end here. If there's any other questions that we can help answer, please, by all means, drop them in the chat window, and we'd love to get to them. While folks are, thinking about that, or, typing their questions, we have some resources here. There was folks that were asking for, the slides and the notebook. But yeah, the best way to get in contact with me is to sign up for the community edition, which is free. The license doesn't expire, and your reward is you actually get in contact with me, or punishment, depends how you look at it. But I also have my email at the bottom there. But it's great to sort of get in touch with folks in the community like yourself. We also have, the ability through that community edition, you can install in Azure, other clouds, as well as take advantage of GitHub code spaces. I think you get about 60 free hours of, cloud resources a month. And so it's a great opportunity to sort of get your hands on. And if you go to docs.wallaroo.ai, you can, go through our host of tutorials. We have hands-on workshops there as well. Also, our GitHub site has a number of tutorials and workshops as well. On the Azure Marketplace, we have about 10 free common VMs through some of these LLMs, such as Llama, as well as Hugging Face. We also have CV, computer vision, inference servers for, ResNet, etc. So yeah, I mean, these take minutes to, set up. And, again, you can sort of get hands-on and start playing around with these production environments. As I talked about, please, I love, connecting with, this community, and I'd love to hear from you. What are you sort of coming across in the, your day-to-day, works with LLMs or other AI models, and developing them and getting them into production, as well as, any other sort of questions that I can help answer. That's what I'm here for. So just finally, I want to say a big thank you to the Actor team. Again, fantastic, and really appreciate them hosting us here, as well as my colleagues Akmal and Yunus. Great discussions and demos, and then also you, the audience. I mentioned at the beginning that these things take up time out of your day, and really appreciate that you chose to spend that time with us. The recording will be available on YouTube, and what we'll do is we'll put some resources in the description of that video when it is available as well. Thank you very much, and looking forward to future sessions with you, and appreciate any and all feedback. Thank you. Bye-bye.
Thank you, everyone.
Thank you, everybody, for joining. Thank you to our presenters for an amazing session. We are always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23187. We'll see you on the next one.